Okay. We are now recording. Let me go over a couple of announcements. I can't remember if any of you are planning to graduate either this term or spring. Was it anybody? Okay, and you've already got your application in. Anyone else? If you know of anyone who is graduating either this term or spring term, this is the time. Actually, it's really late for fall term, but spring term, you still have. This is a perfect time for spring term. Now, we're doing a lot of things different this year than we've ever done before. And one of the things we're doing, and it may not be ever done before, but one thing that's different, we're going to have a graduation ceremony after fall term. In the past, we've only done them in the spring. Now we're going to do them after fall as well. So you'll be able to walk in the fall and not have to come back in the spring to walk if you so desire. So this is the time to apply to graduate. There's 3 steps to that process. You first do a degree audit, and then you see your advisor. With that degree audit, you go over what you need. That's why it's a great time to do it for spring, because you get your degree audit, you go over with your advisor, see what you need to take for spring term, and then when we get the spring schedule up, you can go on and get the courses that you need. If those courses don't seem to be loaded, then you can, Rebecca's here, you can get with the department chair or the instructor or whatever and say, hey, I need this course to graduate. Could it be offered in the spring? We still have time to do that. If it can't be, then we have time to do a course substitution. And so it's just lots and lots of advantages to applying early to graduate. So for the rest of you who aren't that close to graduation, remember, apply to graduate the term before you're planning to graduate. Not the same term, the term before. That enables you to get everything lined up and no surprises then when you're expecting to graduate. The last step then, of course, is to apply online. How was that process? Pretty easy? Good deal. Okay. Good deal. The Office of Student Services is seeking students who are interested in becoming note takers. And you can contact Ms. Janine Jones, Student Services Specialist. She's normally on the Birmingham West Campus. Her email address is jjones@lawsonstate.edu. I have a phone number for her as well. They pay you to do so you can actually earn a little bit of money, help another student, and just a win-win situation. The Space Center is also looking to hire peer tutors in the areas of math. Y'all can do that. English, biology, computer science, and Spanish. When I say y'all can do it, I know you can tutor any developmental math, okay? And if with good enough grades, which most of you have, we might even be able to get you to tutor Math 100 if y'all are doing really, really well in it. A lot of you are. Okay, and there, again, contact Ms. Leslie Harper. She's Student Persistence Counselor on the Birmingham West Campus also. But we have a Space Center here. They'll probably be interested in your time too. And that's 929-6383 is the number for Ms. Harper. Now, again, I said this before. I'll say it repeatedly. Tutoring is one of the most rewarding things you can do. Number one, you're helping someone else. Number two, you're helping yourself. I learned math more tutoring people than I did sitting in the classroom. I had to get the foundation sitting in the classroom. I could perform on the test, but when I had to explain it to somebody, I had to really know it. And that has helped me more in math than any other single activity. And then, the third, you get paid for it. So how can you lose on that kind of situation? So, please consider tutoring. All right. Let's get started from the current slide. And I want to know first if there are any questions on anything we've covered so far. Okay? As you see, these modules are pretty short, and they go pretty quickly. You've gotten your second quiz. We are within almost spitting distance of finishing Module 11. So as soon as we finish that, we'll be scheduling the test for Module 11. Okay? Test 2. Any questions so far? Okay? Well, here's sort of where we left off last time. If you're following in your text, this is Module 11, page 18. rule for factoring perfect squared trinomial. Here's the pattern for finding the square of a trinomial. A plus b squared is, you can rewrite it as a plus b times a plus b. So, square the first, twice the product of the two. AB plus AB is 2AB, and then square the last. Okay? Square the first term, twice the product of the two terms, square the last term. Pretty easy. The square of a binomial is a perfect square trinomial. Okay? And the pattern above suggests the following rule for factoring. Guess what we would do? Undo this. So what do we look for? Here's what we look for. We look for a perfect square on the first term, a perfect square on the last term. That has to be preceded by a plus sign. It's not a perfect square if it's preceded by a minus sign. So nothing will be a perfect square. Something times something gives you a minus b squared. That won't happen. And then the middle term has to be twice the product of those square roots. Okay? And then you just factor just as normal. Okay? Or you can unfoil it. Or you can use the AC method. Any of these will work, but if you see something like this, you can immediately say, that's a plus b squared. The key here, the plus here, if it's a plus there. If the first is a perfect square, the second is a perfect square, middle terms, twice the product of the two. If it's a plus, there's a plus. If it's a minus, that makes that a minus. Does that make sense? So you now have a quick way to factor a perfect square trinomial if you recognize it. That's the key, recognizing it. However, if you don't recognize it, you can still unfoil it. You can still use the AC method. They all work. Okay? Nothing special here. So, here we go. X squared plus 6x plus 9. What do you reckon that might be? X plus 3 squared. Perfect. Because that's a perfect square. X squared is a perfect square. 9 is a perfect square. And this is a perfect square of x, perfect square of 3. Twice the product of 3 times x is 6x. So it's going to be a plus because that's a plus. And then the second one? X minus 3 squared. Because same deal, perfect square, twice the product, but with a minus sign, that puts a minus right there. See how it works? Any questions on that? If you don't see it, go on and unfold it. That'll still work. Go on and use the AC method. Still works. Okay? So any way you want to, but there's a sort of a little shortcut. All right. Now, before we get to the focus here, well, let's see. Let's just use that slide and do the take note on the bottom of page 18, module 11, 8 page. 18. Get out of there. Okay. Let me get my pen. Okay. Here we go. 4x squared minus 20x plus 25. Okay? Now, I don't know how you like to do this. I generally like to just go on and assume that we're going to be able to factor. But do you notice anything special here? Perfect square. Anything special here? Perfect square. What's this a perfect square of? 2x. What's that the perfect square of? 5. And what's 2x times 5? 10x. Double that? 20x. There it is. So what you reckon this is? You don't even need 2 sets of parentheses, do you? If you need them, use them. Okay? What would that be then? 2x minus 5 squared. Okay? Now, if you need to spread them out and do your foiling, see if it works, and it will. 2x times 2x is 4x squared. 2x times minus 5 is minus 10x. Another 2x times minus 5 is another minus 10x. That's minus 20x plus 25. You see it? Makes sense. Any fuzziness? Okay. All right. Now, okay. Yeah. And you can check it by going back and multiplying, which we sort of did really quickly, but we did it. Okay, how about this one? 4x squared plus 37x plus 9. Any guesses? Does that fit the criteria? Okay, it fits that this is a perfect square. It fits that that's a perfect square. But is that twice anything? No, it's an odd number. It can't be twice anything. So this one could not be. Now, if that was an even number like 36, it still wouldn't work, okay? But with the odd number here, there can't be twice the product of the two. Because this would be 2x and a plus 3, and 2x times 3 is 6x, and double that, you get 12x. No. This part works, that part works, the middle part doesn't. Okay? So like I said, even if it was 36 or 38, no, it needs to be a 12 for that to be a perfect square trinomial. Will that even factor? What you think? What might you try? Sometimes it might be better to put parentheses down here. Or, since there's multiple factorizations here and multiple factors there, what might you try? What would you try if it was up to you? Say again? AC method. Why not? So what's your A? 4. What's your B? 37. What's your C? 9. What's AC? What's AC? 36. Excellent. I'm going to take this minus sign off because I see it could be confusing here. Okay. And what's your B? We already said it. 37. Okay. Now, what do we need? First thing, I analyze signs. Plus, plus. Everything's a plus, plus. So these two signs are better be pluses. The fact that this is a plus means that the two factors here are both going to be pluses. Okay, no. Both have the same sign, and since this adds to be positive, both of those have to be positive. Okay? What would be your first guess? First guess. 1 and 36. And what do those add to? 37. Ding, ding, ding. We hit it on the first try. Okay? So what do we do with that, besides marking it wrong here? Oh, and that reminds me, a few others came in, and I don't think I gave test back. As I was saying before, one of my best classes ever, and the fact that everybody had the first quiz in, if not the day it was due, the next day, and then everybody got the first test taken, if not on the test day, within another couple of days. So way to go. So Jayla's still not here, right? Zaria hasn't come in, right? Brianna with an I hasn't come in yet. Maybe. Lastacia hasn't come in yet. Kylie hasn't. Gibron. Okay, no. And Rebecca. Oh. Old to the credit. I've been old to the credit. All right, good deal. So way to go. Keep them coming. I've already gotten a few of the quizzes in. Excellent. Way to go. Keep losing my stats here. All right, so what do we do with this? I've jumped the gun on this. I was thinking we might do a trial and error, but we didn't. That's fine. AC method works well too. What do we do with this information we got right here? Yeah, split up the middle term to be that, 4x squared. What would you put? Plus x, plus 36x, plus 9. Excellent, way to go. Then what do you do? Group them, good deal, okay? I'll group them like that. What do you do with the first group? Anybody? Pull out the common factor, and what is that? X, and what do you have left? 4x. A little louder. What do you have left? Plus 1, okay? Plus, what do you pull out of the second one? A what? A 9, okay? And what do you have left? 4x plus 1. Excellent. Now what do we do? Help me. Yes, common factor 4x plus 1. Pull it out. 4x plus 1. And what do you have left? X plus 9. And then the last step is merely to check it. 4x times 4x times x is 4x squared. Way to go. Oops. Way to go. Then outers are 4x times 9 is 36, plus 1 is 37x. There we have it, and then a plus 9. Got it. Makes sense. So that was factorable, even though it had a first term perfect square and a last term perfect square, the middle term was not twice the product of their square roots. So that one you couldn't use the above method, but you still could use AC method. Make sense? Any questions? All right. Now, I think we're ready to focus on factoring a perfect square trinomial, so that's what we have right here. Okay. What might we try? You tell me. Anybody? Does it meet any criteria? Perfect square? Perfect square? What's that perfect square of? 3x. 3x times 5 is 15x. Double that? 30. Okay. What's our answer then? 3x minus 5 squared. Done. Just like that. Of course, if you wanted to unfoil it, you can still unfoil it. If you want to try AC method, still works. But that's the quickest. Perfect square, twice the product of the two. Sign determines what goes in the middle. Make sense? All right, good deal. Y'all are quick. Let's see how they do it. So they write it as 9x squared as 3x in parentheses squared. 25 is 5 in parentheses squared. So that would give you, and they didn't prove that the middle term was twice the product of those two, but they went straight for the jugular and got it. 3x minus 5 squared. Make sense? All right. And to check it, 3x squared plus twice the product of the two, 2 times 3x times minus 5, plus the last term squared, okay? I wish they had put that minus 5 in parentheses square. That would have made it a little more sense, but it's okay. Because the minus times minus is plus, but I don't like the way they did it. That would be 9x squared minus 30x plus 25. Perfect. All right, good deal. Any questions? Checking is not the answer. The answer is that one right up there. And I'll have I've had it happen before, but probably not in this class, as sharp as this class is, that someone will do the work, do it right, then check it, because we always check it, and then put a box around there and say, there's the answer. No, that was the problem, okay? And I have to go back and search, and if I can find that you actually did it, then you get credit for it. But don't block in the problem, block in the answer, okay? Checking it, just verified, okay? Which is a good idea. Always check, but don't think that's the answer to the problem. There's the answer to the problem. Okay. Whoa. That was over quickly. There's a check your understanding 3, which you certainly can do. Anyone feel like you need that done now as a further thing? Okay. Do that as soon as you can out after class. The solution is given on page S5 at the end of this module. There's another one here, though, so let's go to that. Let's go backwards here. Okay. I can leave it. Let's go on and erase it so you don't feel like that's part of the problem. Okay. Whoa. 9x squared plus 40x plus 16. Okay. What's the first thing you do? Say again? Okay, you've gotten into that, and we will do it ultimately. But the first thing, I've been meaning to say this all along, first thing you always check is, are there any common factors? We've gotten away from that, but it's still pertinent. In this one, yay or nay? No, there aren't any. 9 is 3 times 3. 40 doesn't have a 3 in it. 16 doesn't have a 3 in it. So no common factors. Now you want to try your perfect square trinomial. Is that what you were saying? What would that be? A little louder. A little louder. 3x plus 4. Okay, everybody feel like that's still a good choice? Nope, not anymore, because look at that. Square the first, 9x squared, that's good. Twice the product of the 2, what's the product of the 2? 12x. Double that? 24x, not 40. So this is not a perfect square trinomial. Not. So, if it's not a perfect square trinomial, what might we try? What might we try? What would you like to do? AC method? Let's try it. What's your AC? Woo, big number, right? What is it? Say again, 144, is that what you said? Right, okay. Yeah, okay. I want to make sure that was right. Now what should be? 40. Everything's plus, so all the things will be plus. Let's start. What's one possible factorization for 144? Say again? 1 times 144. That adds to be 145. Not going to make it. Next. Help me. 2 times 72. That adds to be 74. Closer, but still no cigars. Next. Now, here's a question. Will 3 go into that? Does anyone know how to tell quickly?
Yes, you add up all the numbers.
Add the digits together, and that when you add 4 and 4 and 1, that would be 9. 3 goes into 9, so 3 will go into this. That technique works only for 3 and 9. That's the only technique it works. Only 2 numbers it works, but it works for those. Of course, even numbers, yeah. If it's even number, 2 will go into it. 3, add the digits, see if that will go into it. 4, See if the last two digits. Yeah, that'll work too. 5. How about 5? What's the rule for 5? The last digit either ends in a 5 or a 0. This doesn't. So 5 won't work on this one. 6. Well, if 2 worked and 3 worked, 6 is going to work. Okay, so we'll know 6 will work. 7. There aren't any rules. Okay, you just have like a calculator. 144 divided by 7 is not going to work. But anyway, there's no rules for 7. 8. If the last 3 digits are divisible by 8, my goodness, if I do that, I already know the answer. But also, if 2 and 4 are, no, that won't even work either. How about 9? We already said it. Add the digits, and 9 will work. And how about 10? Last digit has to end in 0. Pretty easy. So, finding out what will go into it is usually not as bad as it might seem. So, did we determine 3 will go into it or not? Yeah. Okay, 3 will go into it how many times? 48 times? Is that what you said? And that adds to be 51. Getting close, but still not there. Next, 4. How many times will 4 go into it? 36. And what does that add to? 40. Ding, ding, ding. We got a winner here. What do we do with that? 9x squared. Help me. Plus 4x plus 36 x plus 16. All right. I feel like a dentist up here pulling teeth. Okay. All right. What do we do with the first group? Oh, we grouped them. I'm sorry. I should have asked that first, right? Okay. What do we do with the first group? What is it? X. And what's left? 9x plus 4. Second group? Second? I can't hear it. Sorry. 4. And what's left? 9x plus 4. Ding, ding. What do we got? Common factor of 9x plus 4. And what do we have left? X plus 4. And let's check it and see if it works. 9x times x, sure enough, is 9x squared. That would be 36x plus 4x is 40x. Yes, yes. And then plus 16. Yes, we got it. Not a perfect square trinomial. It had 2 of the 3 criteria. The third one didn't have. Can't be a perfect square trinomial. But this one was still factorable. Not all of them will be still factorable, but this one was. Okay? There's a check your understanding for. Anyone need to see that, you think? Or work out on your own? Okay. And then there's the objective 11.4A practice problems. I see 4 on this page and 2 more on the next page, a total of 6. Please do all 6 of those. You need to practice. They don't give you very many to practice on, so please do those. All right, so that ends for 11.4A. All right, so let's move on to 11.4B. Okay. Okay. We have a little ways to go before we get to the end of this chapter. Module, sorry about that. All right, from current slide. Okay, again, factoring polynomials. I'm glad we used another slide for that, and special pilot factoring. That was 11.4. We had another slide there. Here's 11.4B. Factor the sum or difference of 2 perfect cubes. We haven't done any like that, have we? Okay, well, let's see where we begin. Here's where they begin. Remember when I put on the board over there numbers 1 through 10? Maybe did a few more, maybe 11 and 12. Okay? And then we squared them. Okay? I should have left another column over there. In fact, should have left it on the board. How do you cube those? Well, the first column is the number. The second column was squared. multiply them together, and you got the cube, right? So 1 times 1 is 1. 2 times 4 is 8. 3 times 9 is 27. 4 times 16. Big numbers now. 4 times 16. 64. 5 times 25. 125. They do it, yeah. And 6 times 36. Really big numbers. 216. Yeah, guess what? I don't memorize these. If I need them, I'll do it on a calculator or something. But, you know, that's getting way too big a digits for me. But 6 times 36 is 216. 7 times 49, 343. Am I going to remember that? No way. Okay. So I'll just have to check it. So get those numbers down. If you want it on a piece of paper, do it on a piece of paper. If you want it on your formula equation sheet, put it on your formula equation sheet. Okay. Anywhere you want it, so you can recognize those perfect cubes numbers. Not as common to us as the perfect squares, but the perfect cubes. Variable term is a perfect cube if the coefficient is a perfect cube and the exponent is divisible by 3. Okay? Each variable is divisible by 3. Okay? Make sense? Let's see how some look. All right. Here's the term, x. What would be its perfect cube? That's a real hard one. X cubed. Hey, winner. Okay. 2y. What would be the perfect cube of 2y? I'll be reading my armpit, okay? What would it be? Never mind. Okay. Perfect cube of 2y. 8. Y cubed. Exactly. Okay. 2y times 2y times 2y. 2 times 2 is 4 times 2 is 8. And y times y times y is 1 cubed. Okay. 4x squared. What would it be its cube? Not 16. That's the square. 64. 6. X to the 6. Very good. 64 x to the 6. Oh boy, how about that one? 3x fourth y cubed.
27x12.
Okay, so I get 27. That part's right. X to the 12th. Y to the 9th. Ding, ding, ding. There we have it. Everybody see that? Cube the number. That's why I had you write them down. So we didn't write them down. Okay, and then how do you cube the exponents? You triple them. Okay, triple the number. Okay, remember when you're raising a power to a power, multiply the exponents. Okay, so each exponent is a perfect cube of a perfect cube is divisible by 3. All those numbers are divisible by 3. If it's not a perfect cube. Okay. Now. Oh, did anyone need that a little bit longer? I don't mean to speed you through things. All right, everybody got it? Okay. Now, what do we mean by cube root? Well, square root undoes a square, a cube root undoes a cube. So a cube root of a perfect cube is one of the 3 equal factors of the perfect cube, and there's a symbol for it. Okay? Now, what's different for that than the square root symbol? Yeah, it doesn't have the 3 in it. Okay, the square root symbol doesn't have the 3. In most instances in mathematics, if you don't see a coefficient, what do you understand it to be? 1. If you didn't see a exponent, what do you understand it to be? 1. If you don't see an index on a radical, what do you understand it to be? A 2. Okay, that's the one exception. If you don't see an index in the radical, it's a 2. If you do, then it's whatever that number is. Okay? So, what's the cube root of x cubed? X. Cube root of 8x cubed, 8y cubed. Say again? 2y. 2y. Perfect. All right. Any questions on that? Okay. Now, you will run into, not in this section, but in a later section, you'll run into some pretty big, ugly, nasty numbers. Okay? And if you can't see that it's a perfect cube, here's one way to do it. It's our good old prime factorizations. Okay, remember that? So let's do, let me get my pen picked up. Okay, let's do this one. It's the cube root of 8. Well, 8 is, what's the smallest prime number that will go into 8? 2. How many times will it go in? 4. Is 4 prime? No. What's the smallest prime will go into 4? Times what? 2, and 2 is a prime number. Okay? And then the y cubed is y times y times y. Okay? Now, since this is a 3 on the outside, gather together any triplets you have. There's a triplet, and there's a triplet. So this would be 2y. So there's a way to do it if you don't see. Y'all saw that. It was really easy. But I just want to show you there's another way to do it. And I guarantee you later we're going to have some big old hairy ugly numbers. May not in this module, but we will in some future module. Okay, so just to keep that in mind. All right, any questions? Okay. So the following rules are used to factor the sum or the difference. I have to follow the book because sometimes the book will do something they don't do here. Yeah, we're okay. The sum or difference of two perfect cubes. Okay, let's back off of this. Okay. Okay. I want you to give me a letter or a number. I don't care which or both. I need a letter, but you can put a number with it if you want to. X? All right, boy. Very creative here, okay? All right, plus or minus sign? Minus. Another letter or number, either one. I don't care. We don't need both. Or both, huh? Z. Okay, X minus Z. Okay, I want you to multiply that by something I'm going to make up. I'm going to make this up. X squared plus XZ plus Z squared. Okay? I want you to multiply those two entities together. Now, these are sort of nasty because one's a binomial, one's a trinomial. You can't FOIL them, so you have to do them step at a time. So let's do the first. X times X squared. X cubed. X times XZ. Plus X squared Z. Okay? And X times the Z squared. Plus X times Z squared. You copied me, okay? Now, okay. Next, the negative numbers. I mean, the second number. That will be a, with what sign? Negative X squared Z. And then the next, negative XZ squared. Is that what I heard? And then finally, negative Z cubed. Okay? And what happens if you add all those terms together? X cubed plus 0 minus Z cubed. Guess what? We just came up with two entities. I did anyway. You helped me. Okay? That multiplied to be the difference of two perfect cubes. So therefore, that will factor as this times that. Now, do you want me to tell you how I made up that magic number there? Here's what we did. Okay, first, this number is the cube root of this, same sign minus cube root of that. Okay? That gave me the first number. You gave me the first number. That's how I got it. Now, how did I get the second one? To make sure that worked, here's what I did. I squared the first term. Forget about that now. Square the first term, x squared. Now, this time, it's the opposite of the product. Not twice the product, the opposite of the product. The product here would be minus xz. Opposite of that is plus xz. And then the last term is the last one squared. So I just showed you how to factor the difference of two perfect cubes. Okay? We'll do plenty more of them, so that's how you do it. Okay? Now, you remember how to do the difference of two perfect squares? I know it was a long time ago, but you remember that? I was afraid of that. Okay. How about x squared minus z squared? You know this. I know you know it. Oh, me. It was a long weekend, wasn't it? Oh, I know. Okay. How does that work? X and x here, huh? Second? Plus? Minus? Z, Z. Yes, I knew you knew it. The difference of two perfect squares is the sum times the product of their square roots. Yeah, y'all do that. Those are called conjugates of each other. I gave you that term. Now, I want to ask you a question now. How about this? X squared plus z squared. How does that factor? Long weekend, I know. How does that factor? Oh, it was a long weekend, wasn't it? It doesn't. You can never factor the sum of two perfect squares. Okay. Now, next question for you. Do you think you can factor the difference of two perfect squares? What do you think? Yes, you can. You can't factor the sum of two different squares, but you can do the difference, and you use the same rule we did before. First one, take the cube root of the first, same sign, cube root of the second. Okay? The next rule works well too. Square the first, x squared, opposite the product of the two, minus xz, and then square the last, plus z squared. Okay? Now, I've used up way too much room, so I'm going to erase some stuff here. I think I'll erase this up here, because that has nothing really to do with it. Let's see if indeed that did work. Same way as before, multiply those two, what you get? X cubed. Multiply those two, and what you get? Minus x squared z. Multiply the last two, the first with the last, and what you get? Plus x z squared. Okay, now do the second with the first, and what you get? A little louder. Plus x squared z. Second with the second. Minus xz squared. And second with the third, what do you get? Plus z cubed. And guess what you get when you add them together? X cubed, 0, 0 plus z cubed. So the sum of two perfect cubes you can factor. And it's the same rule as before. Take the cube root of the first, same sign, cube root of the second. And then for the second term, the trinomial term, forget this, and just square this one, minus the product, square the last. Same thing works here as works there in every one of them. Okay? So we now know how to take the sum or difference of two perfect cubes. Okay? So let's see if this agrees with what. Oh, I don't need that. Yes, here we have it. They used a's and b's, right, rather than x's and z's, but the sum of a cubed plus b cubed, how would that factor? First factor? new letters that makes it a lot harder, right? How did it go? Say again? A plus B, perfect. A squared minus AB plus B squared. Perfect. How about that? A cubed minus B cubed. Say again? Yep.
A plus B.
Did I hear A minus B? Say yes. All right, yes, A minus B. Okay. What would be the first term here? A squared plus AB plus B squared. Got it. Okay? See how that works? This will factor same sign here, opposite sign there. This will factor same sign here, opposite sign there. Factors the same way. You just have to remember with the what we were doing before when we were perfect square binomials, we had twice the product of the two. Here is the opposite of the product of the two. Of those square roots. All right, let's do some here. What would be x cubed plus 8? Does that factor? Anybody? First answer, yes or no? Yes. Okay, good. What would it factor as? X plus 2. Say again? X squared. Minus what?
X plus 8. Oh, minus x 8.
Minus
8x,
what?
sorry.
I can't hear.
Would it be 8x?
Minus 2x. Right? The product of the two. Minus 2x. And then
Plus 2.
square the last. Plus 4. Okay? Everybody see that? Or not? The rule is cube root of this, cube root of that, same sign in between, and then square this one, opposite the product, square the last. Okay? How about this one? Z cubed minus 64. Anyone want to make a stab at it? Yeah, stab it. Okay? How would you begin?
C minus 4.
Say again?
C minus 4.
Z minus 4. Perfect. Okay? Next. Z squared plus 4Z. Always squared. Plus 16. Minus 4 times minus 4 is plus 16. Okay? That last one is always squared. Positive. Always positive. If it's not factorable or not by this method anyway. Okay. Now I can almost read your mind. Ooh, that's scary. No. What that you might be saying is, can that factor any further? And guess what? That one trinomial will never be able to factor any further. Don't even waste your time trying. Okay? Unless, of course, you had a common factor somewhere in there that you didn't bother to take out before, yeah, you still have to take it out. But if you had taken out common factors to begin with, which you almost have to, then this will never factor any further. Ever. So that's one you don't have to waste any time trying to factor. Give it up. Okay? Any questions? All right. Now, what you reckon? Do you think that's factorable? Okay. What might be the factorization? M plus, good start, 4n. Okay. And what comes next? M squared minus, help me. 4 M n. The product of the two minus the product of the two. The product of m times 4n is 4mn, right? The opposite sign. So minus 4mn. Next, Next, plus 16 n squared. Ding, ding, ding. I think we got it. Let's check it. Okay. Let's square the first. Multiply the first times first, and that gives you m cubed. First times the second, and that gives you what sign? Minus 4m squared n. Okay. And first times third is plus 16 m n squared. Okay. Next, second time first, what do we get? Help me. Plus 4m squared n, second times second, minus 16 m n squared, and second times last. Last times last. Plus 64 n cubed. And these go out, and you're left with m cubed plus 64 n cubed. Exactly what we started with. Yes, we did a correct factorization. There's your answer. This isn't your answer. There's your answer up there. You can lose some of those lines around it if you want to, or just make that a big box. I don't care. Okay. All right, everybody see that? Any questions on it? Any questions? Ask them. Don't sit there. Okay. All right. Glad you said that. Okay. So, let's start back over. Let's just erase it all and start back over. Okay? All right. Now, first is recognition. Is that a perfect cube? Yes. Is that a perfect cube? Okay, what's that a perfect cube of? 4 n. And that's a perfect cube of m, obviously. Okay. So since we got what they're perfect cubes of, that gives us our first term. What was the first one? M sine plus 4n. Okay, you got the first one. Okay? Half the problem's done. Unfortunately, it's the easy half. Okay? That's the problem. Okay. Now, I've never seen anyone do this way. It always works for me. And I don't have to memorize. I hate memorizing things. I'm really terrible at memorizing. Okay? But this is the technique I came up with, and it works. So it works for me. If you don't want to use it, memorize what they gave you. Okay? You square the first term. What would that be? M squared. Okay? Then you do opposite the product of the two. What would that be? This times that, huh? Minus 4 m n. Perfect. And then you do square the last term. Plus. And that's always, when you square something, it's always plus. What does it give you? 16 n squared. You just did it. All by yourself. Sort of. Okay? That's how you do it. Okay? And you can go back and check it if you want to. If that gets too confusing for you, hope you got it right. Okay? But it's always a good idea to check. Okay? Does someone want to see it checked again just to see what we were doing with checking? I'll be glad to do it if you want it. Yay or nay? Okay. All right. Let's see how they did it. Okay. First thing they did was exactly sort of what we did. Were y'all in here when I pulled this off? Yeah. Okay. That's why I keep doing this, to make sure I'm not dragging it down. They saw this is a perfect cube of m. This is a perfect cube of 4m. They did that. They wrote it this way. If it helps you to see it, write it this way. I don't see that it's helpful for me, but that doesn't mean it's not helpful for you. So if it is, write it that way. Okay? Now that tells you where to begin. This number plus that number. That's where you begin. That's going to be your first factor. And that's exactly what they do. M plus 4 Henry. Close. Okay. Now, they don't say this. They just say, here's the rest of it. You have to memorize the formula. This is what it is. Okay? To me, I want to have some sort of method. Now, there may not be any mathematical plausibility of why this works. It just works. Okay? Square the first term. That's easy, right? Okay? Opposite the product of the two. Square the length. There you have it. They use this model here, and then you plug in what A and B is and stuff like that. If that helps you, then do it that way. But this rule works for me. That way you just have to memorize the formula. This way I have my little other things I remember to do. Okay? All right. Any questions on that? So that's your solution. Oh, goodness gracious, that's all that you wrote, wasn't it? Okay. And again, I wasn't paying attention to the book. That was their focus number 2. We didn't do, okay, let me erase this. I wasn't paying attention. I'm not used to this book, and they do some weird things here. But anyway, let me make sure we did the other. Yeah, we did that. And what I didn't pay attention to is this. Here's another one they had you do. Factor 64x cubed minus 125. Okay? You reckon that's factorable. Why?
64 is the perfect cube of 4 and 125 is the 105.
Okay, we got 2 perfect cubes there. So the first term will be 4x minus 5. Okay. Then what will we do next? I got the little parentheses done. I still got the big one to go. What do we do here? Help me. Square the first, and what gives you? 16x squared. Then plus, a little louder. You probably said it right, I just don't hear well. Plus 20x, you got it. Okay, I thought that's what you were saying. And then next. Say again? No, it's a plus. 25, perfect. That last one's a perfect square, so it has to be positive. Okay. No, just plus 25. Plus 5 squared if you want to put that. But to me, that does an extra step, and I'm too lazy for that. Okay? Not that funny. Okay. Now, what do you want to check it? That's not too confusing? Okay, let's check it. Make sure we got it right. 4 times 16x squared is 64x cubed. That works out well. 4x times 20x would be, help me. 4x times 20x plus 80x squared. And then 4x times 25 plus 100x. Okay? Then the second times the first, that would be negative 80x squared, 80x squared, right? Second times second, negative 100x, and second times third, negative 125, ding, 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 yes, 64x cubed minus 125, just like we had there. Okay, makes you feel warm and fuzzy inside, right? Good deal. Okay, I take it from all the motion, it must be close to time. Is it? Boo hiss, how could it be? All right, I've already been giving you some homework exercises. One I didn't say before, the check your understanding 5, we didn't do that one, but we did do the problem for it. So you do that. We'll start next time with focus on factoring the difference of two perfect cubes. Okay? You can start working on the objective 11.4B practice problems. There's 5 of them there. Solutions on page S10. Okay? So we'll pick up and go from there. Any questions? Good deal. We will see you on Wednesday. Good deal. Thank you. Yes. Oh, let me say this. I meant to say it before. No one mentioned how I was dressed. I've got a funeral to go to this afternoon, so I won't be in the office from 2 to 4 like I normally am. So don't be looking for me. Yeah.
I won't be able to say. I gotta
You
go
want?
for Benny.
Yeah.
For my leg.
Uh-huh. How's it coming?
Doing good. I gotta go for my 8-week postdoc or something.
Oh, okay.
And is there a way for me to get that quiz?
No. Of course there is. Okay. Anyone else did not get the quiz?
No.
Oh wait.
I didn't get the quiz too. I never got it.
That's what I'm asking. Anyone else need that? Okay. I passed those out earlier, but you weren't. How in the world do things get so screwed up here? Test one. My word, that's another course. How did that get in there? Okay. Now I'll get it to you. Just hang on. Let me get these. Oh, I know how. They got turned over. All right. Good deal. Thank you. Okay. Test one. Quiz 2. There you go.
Okay.
I want to give this to you, but I'm not sure about number 9.
Okay. What is it you're not sure about?
Well, I don't think it's factorable, but
Okay.
it could be. One was a -1 times 7,
Yeah. I don't recall the answer on that one. Let's just take a look at it and see. Could be a X. Yeah, I have a feeling not, but if that was a minus sign
right.
there,
It would be, but
Yeah,
it's
so I
not
think
because
that's
it's too
probably
positive,
not,
and positives aren't.
Yeah.
Okay, then you can have it.
Okay.
Sorry.
Okay, she let me have it. Okay. All right. Good deal. And I was recording.